For part 2, we're going to start taking a look at how polynomials can affect inequalities, or how we can use polynomials to indeed solve inequalities. So to begin with, we're just going to do the same thing we've always have done. We're going to sketch them. Ignore the greater than or equal to 0. We're just going to sketch the function. So we need the type. -2, this is x squared, x, so we get -2x cubed. It's odd negative. So it's going to look like this. Starts up, ends down. Odd negative. Next, we can get the roots now because we're already in factored form. So we can go ahead and actually get the roots. Our first root is this x equals 3. Be careful, it is m2. And we have x equals -4. And then we get the y-intercept. Let x be 0. We get -2. -3 squared is 9 times 4, and we get -72. And I sketch this. Let's see, my roots, my y-intercept. My roots are at 3, that's m2, and -4, and it crosses the y-axis at -72. It is odd negative, so it starts positive, ends down. So when I sketch it, it's going to go through the -4, through the -72. Look, I made my little bump right here. It doesn't matter where you put it. Remember, this is a parabola right here, so at 3 it has to look like a parabola and goes back down. Now, let's answer the question. The question says, when is our graph greater than 0? So, if you look here, when is the graph f of x greater than 0? This is saying, when is the y values greater than 0? In other words, we want it to be above the x-axis. And where's the only place where it's above the x-axis? That's right, before -4. So we would write it as x has to be less than -4. Or sometimes we may write it this way. -infinity to -4. Now soft brackets because it's only going to be greater than. If I wanted equal to, then we could write it as a hard bracket. And there's our answer. So you guys go and try number 2 and 3, and we'll go over these tomorrow in class, Monday in class. Thank you. Bye-bye.